Today we are going to talk about parabolas again. Parabolas are something that we have talked about a ton in your math studies so far. So parabolas, quadratics, it's a U-shaped graph. So before we looked at parabolas, it was defined by an equation ax squared plus bx plus c, and this is where we learned all our factoring and everything else that we would do with this. But it was a U-shaped graph that either opened upward or downward depending on whether the sign of A was positive or negative. Lowest point of the parabola was called a vertex, and it was symmetrical about its axis, right here in the middle. Okay? What we're going to do now is we're going to expand upon that because there's another useful way to define this that will help us out later on. Actually kind of explain some of the things that we may use every day in our life. One particular thing, things like these right here. Glasses and things like that are helped explain by parabolas and how they work. So we're going to expand this definition and study parabolas from the geometric rather than the algebraic standpoint. There's going to be an algebraic definition we're going to use, but we're going to look at the geometric definition of this first. So geometrically, when we start talking about distances and lengths, a parabola is a set of fixed points in the plane that are equidistant from a fixed point called the focus to a fixed line called the directrix. So lots in there. So equidistance, straightforward, that is a equal distance. So two distances that are the same. So all the points on the parabola are all the same distance from a line that we draw and one point in the middle called the focus. And what that would look like is it looks like this. So here's our parabola in red. And when we look through this, there's our axis of symmetry that we talked about up there. There's a focus that's in the middle of this shape, this parabola. And what this does is the distances from the focus to the edge of the parabola, and then from that point on the edge of the parabola down to a line down here, a horizontal line, those distances are equal. And anywhere I move that point on the edge of this parabola, those two distances always remain the same. That's exactly what our second picture I have right here for us says. The two distances from here to here, no matter where I move that point, are the same. And we can prove this with coordinate geometry, which I'm not going to go through today. But the proof is in textbooks, and it's in our textbook if you'd like to look it up. And it's in the section on parabolas, conic sections. Just let me know and I'll send you what page it's on. But I promise you it works. And what happens is going through this geometric definition where we find distances and everything else, we get two really pretty equations that make this work and make it so we can find this point, this focus point, and this line called the directrix. Because this focus point, this is how we make glasses work. So we can focus light into the correct spot in the back of our eyes, make us see better, okay? So two equations. Here's our two equations for parabolas. So an equation of parabola with focus at 0p or p0 and a directrix at y equals negative p is, well, there's two of them. Let's start with the top one. X squared equals 4py. Now notice this is different. You see the same thing down here. We're putting this square term over here by itself, all right? But when we have x squared, we get two different types of parabolas that can happen. One of them, our parabola is going to open upward. The other one is going to open downward. And notice right now, that both of these things they have a vertex in a very special spot, okay? Unaltered, untransformed, which we'll talk about transformations later on. The vertex of this thing is at 0, 0 for both of them, okay? That's an unaltered parabola. That's just like we started before. Unaltered parabolas were at 0, 0, okay? So unaltered parabolas that open up and down are going to be x squared equals 4py, and they're going to have a vertex at 0, 0. So the other 2 points that we want to figure out, or the two features we want to figure out, is this focus point and this line that is the directrix. And notice these are defined by the variable p, which is in the equation. Now the way that we tell the difference between one that opens up and one that opens down has to do with this value of p that we'll see when we get to the equation. If it opens up, p is going to be positive. If it opens down, p is negative. So to get ones that open up and down, if it opens up, it means it's an x squared, and its p is going to be positive. When it opens down, it's going to have an x squared in it, and its p is going to be negative. Now, with this definition, that means we can actually get parabolas that open left and right as well. So down here we have one that opens left and one that opens right. And notice that now instead of our directrix being a y equals line like it was up here, it's an x equals line because we're opening left and right instead of open down. And instead of our focus point being on the y-axis, so having a p-value for this, notice the x value has the p on these. It's the p0 on both sides, okay? Now, to open right, we're going to have a p-value that is positive. So to open right, we'll see a y squared, and p is positive. To open left, we're going to see y squared, and we're going to see that our p is negative, okay? So to start this is a lot to take in, and it's going to be a real challenge over distance ed, but we're going to do it. We got this. What we're going to do is we're going to get our equations to x squared or y squared, and then solve for p, because once we know for what p is, we can use p to find the directrix and the points, mainly the focus point, because the vertex point's always going to be 0, 0 for us to start. And then we can graph it, sketch a graph, and know which one it is. So that being said, this gives us our general overall view. Vertex is going to be at 0, 0. Focus is going to be 0p or p0. And our directrix is always going to be y equals negative p. Now notice that p, negative p, we talked about whether p is positive or negative. That's going to switch the sign to put everything in the right spot by whether p is positive or negative here, because negative is going to make it positive, so on and so forth. And we'll see that as we work through some. One other thing about this that you might see come up is called focal diameter. Focal diameter of a parabola is 4p, and it's the distance to the focus, right here, to either side on the edge of this graph. So I could draw a line here through this space right in here, like that. That distance right in there, which I didn't get right exactly through p, but I got pretty close. I can move it down one. That distance right there is the focal diameter. I could draw one on each one of these things. Horizontal to the directrix, through the focus, and it touches the two edges, and that distance right there is always this value of 4p that will be inside the parabola in case that were to come up, okay? Well, we're mainly going to focus on finding these points and just kind of determining what it looks like. So first example here. I want to find the equation of the parabola with a vertex at 0, 0 and a focus at 0, 2. And then sketch the graph of it, okay? So right off the bat, finding an equation. So vertex is v, and it's at 0, 0. So let's go down here. Let's put that point on here. So its vertex is at 0, 0. Its focus is at 0, 2. So that means we're going to count up to 1, 2, put another one here. Here's the focus, and here's the vertex. Now, how does that help me? And I see I have it up here. So since the focus is at 0, 2, we can conclude that the directrix is at 0, negative 2. Why? Well, because the focus tells me what the value of p is. So since p is 2, that means negative 2. That's negative 2. That means the directrix is y equals negative p. So that means the directrix is down here at negative 2, while the focus is up here at 0, 2. So that means that our line, I'm going to draw it in here, it's horizontal, and it's going to go through at negative 2. And I missed negative 2, so I'm going to move it up there on top of where I had it. That's where our directrix is. That's where our equal distance comes through. And our parabola is going to open upward. Why is it going to open upward? Well, because the focus is inside the cup of the parabola, the cusp, where it's really called concavity. But notice that it's inside each time. So the vertex is always below, focus is here. It tells you it has to curve in between those two items. So that means that our parabola is going to look something along the lines of this. Minus a little bump there. Now, we can find the other 2 points on this thing using the idea of the focal diameter, because we know if we were to draw another line in here, straight across right in here, we know that that distance of that line, called the focal diameter, should equal 4p. And since we know p is 2, 4 times 2 is 8. So that focal diameter is 8. But it's also, because this is the axis of symmetry, it's split evenly, meaning that I know that this part is 4 away over here. So that means that I know it's too tall, but that means this other point over here has to be at 4, because from 0, 4 over is 4. So that's going to be the point 42. This distance is going to be 4, but because we're counting backwards, that's going to be negative 4, 2. I could find other points on the graph. Now the only thing we haven't done is the first part of this, which was the equation. So this is going to be an x squared because it opens upward. P is 2, so that means we plug in that 2. 4 times 2 gives me that 8, and there we are. This is the equation of that. Now what's really nice is if you take this to Desmos, hold on, my pen's having some issues here. And you plug it in, you can plug in x squared equals 8y. And it's going to graph a parabola that looks like this. Now it's not going to label the focus and it's not going to label the directrix like I did, but it will give you the parabola to help you double check that. So make sure you use that to your advantage as we go through and work with this. All right, let's try something else. So we're going to find the focus and the directrix of this parabola. So this is y equals x squared. Y equals negative x squared. We kind of already know, even not knowing anything about this as a conic section, which is what we're learning right now, what this looks like. This negative means it opens downward and stuff, but it doesn't help us find the focus and the directrix. But with this, we're going to use this one to help us find the focus and the directrix. X squared equals 4py. What we need to do is we need to find p. So let's put this in the right order algebraically and figure out p. So I'm going to put the negative x squared over here by itself, and we're equal to y. Now the thing we have to get rid of is we have to get rid of this negative. So that means this is x squared equals negative y. What number should be in front of this? It should be a 1. Because this is important, because this 1 right here, this tells me what 4p is. So if 4p is equal to negative 1, divide that 4 over, means p is negative 1/4 or negative 0.25. Now, x squared, p was negative, that means that our parabola is going to open downward. And the reason we need to keep track of this stuff is it'll help us make sense of the coordinate. We know that our focus is going to be down here, and it's going to be 0p. Up here, we're going to get the equation of our directrix, and this is going to be a y equals or an x equals. This is going to be a y equals because it goes through the y-axis, and it's going to be negative p. Now we keep track of this because we're going to plug in the number that we found for p. So we figured out that p was a negative number. That's going to make all this work out for us. So when we find the focus is 0p. So we plug in that, and that means that our focus is 0, negative 0.25 or negative 1/4. Our directrix, which is an equation, that's going to be y equals negative p. So that is y equals negative 0.25, which is why it's above and it's in the positive, because this is y equals negative and negative give you a positive. That's 0.25. So there's our focus and our directrix from that equation. Let's try another one. Find focus, vertex, and directrix, and then we're going to try to sketch it, see what we can make it look like. Okay. So remember these we've got to get the squareds by themselves. So let's look at that. We got a y squared. That means y squared needs to be by itself to set this up. So let's turn it around. Y squared equals x. How do we get rid of the 2? We're going to divide it. So there's a 1 in front of this. That means this is 0.5. And now remember, this number right here, this is 4p. So we have a y squared and we have a positive. So which way is that going to open? It's going to open up, down, left, or right. Well, let's go back and look. Well, let's finish finding the p first so we can actually compare the p, because I defined those by p. So this is 0.5. So that means, let's actually go through and plug this in. What is 0.5 divided by 4, folks? So we'll plug it in. 0.5 divided by 4 is 0.125, which is 1/8. So it's 1/8 or 0.12, sorry about that, 125. So let's go back and look and see what that positive p with a y squared tells me. So we know it's one of these. We have a y squared, and p is positive. So that means that we're going to open right. So that means that this one should look like this. Now, what did I tell you about the vertex of all of these so far? The vertex is always going to be at 0, 0. So that makes that an easy thing. So it's not going to be a y anymore, I'm sorry. That's going to be an x, because we went through the x-axis. X is negative p, and since we're on the x-axis, these are going to be p0. So based on what we found for p, our focus point is, I did it again, I put our 0 first, I'm sorry, is 0.125, 0, which makes sense because it puts it over here to the right. Our directrix line is y equals negative, or sorry, x equals negative p. So that's going to be x equals negative 0.125. And the vertex always starts at 0, 0. So we could label all those things into just this picture right here and make that fit. But I have it drawn out a little bit nicer. There's all of our good answers right here. We should have got one that opened to the right. And so if you're just making a sketch, which I won't ask you to do, a lot more matching, I think we're good. All right, one more. So find the focus, vertex, directrix, and sketch, just like we did last time. So this one's a little bit different because we got a plus in here, okay? But we have x squared still. So that means this is still a parabola. And to get this the way that we want to see it, we got to get this x squared by itself. So what do we do to get that x squared by itself? Well, we've got minus this 4y. So this is x squared equals negative 4y. So that means that this negative 4 right here is our 4p. So if 4p equals negative 4 divided by 4, our p is equal to negative 1. So we have an x squared with a negative p. That's going to open down. So our p value here is going to be 0p, and up here for our directrix line is going to be y equals negative p. So let's list these things out. Now we know the vertex is going to be at 0, 0, so let's list that first. These are unaltered. We're going to talk about what happens when they transform tomorrow. Our focus point is going to be at 0, negative 1, because p is negative this time. Our directrix is going to be an x equals or y equals. It's going to be a y equals. It goes to the y-axis. And it's negative, negative 1, meaning that this is y equals 1. So we could sketch this thing out, count up to 1, count down to 1. This is 0, negative 1. This right here is a line at y equals 1. And lastly, our vertex is right here. We know this is going to go like this, up and down. Now, one thing we can find is, because we know about the focal diameter here, we can find these other 2 points over here. Let's label them in blue. Because 4p, which was negative 4, that's the distance here. Now remember, distance is always going to be positive. So the distance of this whole line is 4. That means this distance has to be 2, and this distance has to be 2. So that means that this is going to be 2, negative 1. Because we're going to count to the right 2. This one is going to be negative 2, -1. Left 2, down 1. And that's exactly what I have drawn nice right here. So lots of practice. Focus on just finding these focus vertices and directrix right now. Remember, right now, vertex will always be at 0, 0. That's where it's always going to start. We'll deal more with transformations and stuff tomorrow. Let me know if you need help. Bye, guys.